Hello, I'm Tom Benton, a researcher at Cambridge Assessment, and I want to describe to you some work we've been doing over the past couple of years to try and understand why schools' GCSE results vary as much as they do. Now, schools have expressed a lot of concern about their results being variable, going up one year, down the next. This quote comes from a report from HMC, cites the fact that schools often see changes of 10% in their GCSE results as showing that something is self-evidently wrong with the exam system. In addition, headlines about concerns over variability are common. This headline is from the GCSE Results Day TES in 2014, with the text of the article referring to a school who saw their GCSE English results drop by 18%. Again, the context suggests that this is a self-evident problem with the exam system. In light of concerns over volatility, the exams regulator Ofqual produce reports every year monitoring the situation. This is a typical conclusion from one of these reports where they note that while most don't, some schools do indeed see large changes in results. However, they don't say whether this is to be expected or whether it's a problem. Cambridge Assessment has done some previous work on volatility and ruled out some of the possible causes. We know it can't all be about marking, for example, else wider subjects that should be easy to mark, like maths, display nearly as much volatility as those that are thought of as harder to mark, like history. It also isn't all about where we put the grade boundaries. We know you can put the grade boundaries wherever you like. You still get volatility. Finally, we also know that volatility was slightly reduced with the move from paper-based marking to on-screen marking. So we know that that move isn't the issue either. However, while we've ruled out some causes, none of this research tells us how much volatility there should be. To answer that question, we're going to apply some simple statistical formulae that have been available for over a century. We're going to work out how individual pupils' results can be predicted by their ability as measured independently in other GCSEs. Then alongside this, we quantify how much uncertainty there is for each individual student. This uncertainty might result from some students being better at some subjects than they are at others, or it might come from the specific content of the exam happening to suit them more than expected. That might have a little effect. Then we build from the bottom up all these uncertainties and predictions for individual pupils to work out what volatility ought to look like for schools at the national level in a stable system. This chart shows the relationship between the grades in GCSE English Literature in 2015 and achievement in other GCSEs. As you can see, there is a strong relationship. The higher your average grade in other subjects, the better your chance of getting a good grade in English Literature. The correlation is about 0.8, and in all honesty, we wouldn't want it any higher because different GCSE subjects are supposed to be measuring different skills. If they all gave the same result, what would be the point of doing them all? Note that even with the strong relationship we see in this chart, there does remain a little bit of uncertainty in pupils' results. Even a candidate who is averaging a C on their other exams, we're using the old grade system, could still potentially get an A in English Literature, although this only happens in about 1 in 20 of these cases. This might be because they're better at English Literature than any of their other exams. Or it might be the particular exam questions happen to coincide with something they've really revised and are strong on. Or there could be other reasons. But whatever the reasons for this uncertainty, we do need to take account of it when we think about volatility at a national level. We can use this same model to calculate what we might expect to happen for whole schools. This chart shows an example for 10 random pupils in a given notional school in 2014. And it shows each pupil's chance of getting a grade C or above. Now, for some pupils, like pupils D and F, given their performance elsewhere, we're extremely confident that they're going to get at least a C. However, there are some pupils, we might call them key marginal pupils, where we are far more uncertain about their outcomes. Pupils G and J might be in this category. When we combine all these results together, Using standard formulae from probability, we can predict the range of likely outcomes within this school of 10 pupils. We'd expect around 7 pupils to get C or above, but we wouldn't be surprised if as few as 4 or as many as 9 out of 10 got C or above. All of this is within the expected range. Now, to look at volatility, we need to consider uncertainty across 2 years. So we need to repeat the same exercise for 10 more pupils in the same notional school, but this time in 2015. In this case, we again expect 7 out of 10 to achieve a C or above, but in reality, only 5 did. This might be disappointing for the school and for those pupils, but statistically is well within the normal range that we'd expect. Finally, to look at volatility, we need to combine predicted results and uncertainties across both years. Because we're combining uncertainties, the range of possible outcomes surrounding change is larger than for results in an individual year. Now we want to use this procedure to look at what we'd expect from volatility nationally. Here are the steps. Using data from the National Pupil Database, we start with the lowest level of analysis and calculate expected results for each individual pupil in the country. We combine these predictions within each school to get an idea of expected results within each subject for every school. Next, for each school, we look across 2 years, for example 2014 to 2015, to work out how much variation we might expect. And finally, from these calculations, we build up a picture across all schools to work out what we'd expect the volatility distribution to look like nationally. For further details on this procedure, read the full report. Before showing the results, it is important to understand the assumptions behind the calculations. The important thing to note is we are assuming that the only thing that changes between years are the pupils who happen to be in each school. So, the only possible causes for volatility we have allowed in our simple model are that schools might get a better set of pupils in one year than they did in the previous year, and that there's some uncertainty for individual pupils. They might be better than expected at particular subjects. More importantly, we're assuming no change in the quality of teaching or anything beyond the pupils within schools between years. We're assuming that is completely and utterly stable. Every teacher is exactly as good in 2015 as they were in 2014. Taking this assumption, here are the results. The blue shaded area displays how much volatility we'd expect even if nothing had changed apart from the pupils. The orange bar show the actual amount of volatility at the national level. What's the main thing we notice? Well, the 2 lines, predictions, are almost the same. So we certainly expect some schools somewhere to display big changes in results. Changes of 10% are not unusual. We'd actually expect 1 in 5 schools to display this level of change even if the quality of teaching hasn't changed at all. Why? Because they're teaching a different set of pupils. Now, these results are not just true for English literature at grade C. Similar findings can be shown for a range of subjects and at other grades. Details of this analysis are in our report. So to summarise, a large proportion of volatility can be explained by easily observable information about pupils, namely how well they've done in other exams set and marked independently. Remember, our predictions were based on a very simple model, but were still quite close to reality, even though they assumed nothing changed between years other than the pupils that attend different schools. What can we conclude? Well, if volatility was any smaller than it is that will be worrying. It might indicate that attempts at improving classroom teaching never make any difference. That would be worrying. If volatility was smaller, it might even indicate that results were being fixed to ensure that the rank order of schools was always maintained. Again, this would be worrying. In other words, if volatility was any smaller, that would be a bad news story. If it was smaller, it would be that would mean the exam system was broken. Here are some important implications. Firstly, GCSE results in individual subjects cannot all be about subject teaching. This means teachers should certainly not be judged on a single year of results. Finally, we need an awareness of how much volatility to expect in school results within a completely stable system. Only if we're aware of this are we not going to be constantly surprised by changes that seem large. If you want further details on this research or anything else we've done, go to cambridgeassessment.org.uk/our research.